Welcome to everybody who is joining us. Welcome back to Stormwater Awareness Week. This is the second to last workshop of the week. We've loved having you here for Stormwater Awareness Week 2024. This is the 5 Fundamentals for Developing Sustainable Vegetation on Construction Sites workshop. It is 1 o'clock, so Colin, if you'd like to introduce yourself, we can go ahead and get started.
Perfect, thank you. So my name is Colin Hewitt. I'm from Profile Products, LLC. We're a manufacturer of hydraulically applied erosion control. We've been in the erosion sediment control industry for 12 plus years, working in various different aspects in relation to BMPs. So today we're going to actually talk about developing sustainable vegetation on construction sites. If you have questions as you go along, feel free to put them in the chat box, and then we will deal with them. We'll leave about 10 minutes at the end for questions, and we'll cover any particular topics that you've got. If it's a large topic you want further information, then feel free to reach out to me. My contact details will be on the last slide of the presentation, and you can take an offline follow-up with me if you wish to. So let's get started. So a little bit about Profile. We're basically, as I mentioned, we're a hydraulic product manufacturer. So we manufacture everything from recycled wood and plant materials, and it basically is hydroseeding and erosion control products that are applied with or without seed to slopes. Today we're going to cover the 5 fundamentals: creating optimal soil conditions, picking the right plant species, selecting the correct erosion control material, and ensuring proper installation, and then follow-up inspection and maintenance. And then, as mentioned before, we'll deal with some Q&A at the end if you've got questions about the topic matter as we go along, or the subject matter as we go along. So one of the things we like to discuss is, the most effective form of erosion control on construction sites, and probably comes as no surprise to any of you that is sustainable vegetation. Really, what we want to be doing is we want to be looking at, initially in construction sites, can we prevent removing vegetation? And if we have removed it and done slope stabilization, soil movement, etc., can we restore that back to sustainable vegetation as quick as possible? This is the single most effective way and cost-effective way for long-term stabilization. The root systems that get in there stabilize the subsoil and the canopy of the plants above the ground. As they take that raindrop impact, they remove that energy and prevent the rain from directly impacting the soil. And then, of course, with all the little stems and roots and vegetation, as it lays down flat, it prevents that and slows that flow of water down the slope and helps us to prevent erosion. So how do we go about doing this? Creating optimal soil conditions. So this is fundamental number 1. We always say start with a soil test. Evaluate your soil fertility. Look at, what the potential problems and obstacles are in terms of establishing vegetation. This is probably the single most important thing that you can be doing on your projects, is doing some sort of soil testing of that soil if you plan to grow vegetation. If you don't plan to grow vegetation, soil testing is not for you. But we find that more often than not, when soil testing is not done and there's a failure, that's when soil testing is done. So we're big advocates of getting it done, be proactive about it, and see what you're dealing with before you actually start planting your plant species and everything else. This is a little bit like going to the doctor and saying, well, I don't feel well, and then they just turn around and give you a prescription. Well, they don't know what's wrong with you. They usually order tests, and then based on those test results, they'll turn around and say, this is what we're prescribing. So when we're testing soil, we're testing for basically the buffering capacity, pH levels. pH level is critical in soil. It is probably the single biggest effector of whether or not you're going to have sustainable vegetation growing in your site. It's very easy to get plants to germinate and come up. Oftentimes, we get a month or 2 down the road and the plants don't look so well. So what often happens is people they water more, then they realize that that's not solving it, so they water less. That doesn't solve it. And oftentimes we can draw down to one of these particular elements being wrong. Either we have toxic levels of certain elements in there, or the pH is far too high or far too low. And those are things that we can correct as we go into it before we even start the project. So again, soil testing, so we know what we're dealing with. In a soil test, we're looking at various factors. We're looking at texture, organic matter, pH, bicarbonates. I mean, so there's a whole list of products that we're testing for. And there are, in the green column that you can see here, an ideal range or optimal range that we're looking for. And with most of these, we can actually, when we're spraying a hydraulic product down, we can actually adjust a lot of these to be within the parameters that we need to be. So we can add pH adjustment into a tank with hydromulch with seed and get it back into parameters so we've got ideal conditions for growth. So nitrogen, phosphorus, potassium, you're all probably very familiar with what that is, the NPK that's in a fertilizer. Something to understand is that when you're looking at those numbers that are on the bags, so 20-20-20 is usually the percentage of the formulation of each of these nutrients. So in this case, it would be 20% nitrogen, 20% phosphorus, 20% potassium by weight. The remainder of whatever's in there is usually just some kind of filler carrier or other material that's just designed to make sure that this gets dispersed into solution properly. So pH, basically, other than water, it is the single biggest impact on whether you're going to establish vegetation. We'll see this a lot in areas where you've got pine forests that have been growing on whatever site's being developed. We'll often see really low pHs. In areas like if you get over towards Salt Lake area, we tend to see very high pHs. I will tell you that there is nothing to tell you that if it's here, it's going to be high pH or low pH or ideal. You always want to be soil testing. I would recommend that if you are soil testing and you don't want to test for everything, at the very least, test for pH. This is the single most critical factor that affects successful implementation. So the reason pH is important is if you look at the chart that's in front of you, let's just take nitrogen, for example. So in the ideal range in the center of the column there between 6.3 and 7.3, you can see nitrogen is available to the plants. As we go into the acidic phase heading towards 4.0, you can see as that little tapers off and the availability of nitrogen is severely diminished. And then in the case of high pH, it's the same thing. That's not true of all things. For example, if you look on the chart for sulfur, sulfur is only affected by low pH, but is not affected by high pH. So ideally, we want to be at 6.3, 7.3 in terms of range on pH to make sure that we've got the availability of nutrients to the plant species. So when we come into a typical site, if we were to look at soil just out in the middle of a field, this is typically the horizons that we'll see. We'll see the top 12 inches roughly is what we refer to as topsoil. Below that, we're looking at subsoil, and then below that, we're looking at substratum. The reason this is important is because that topsoil is where we have all our organic matter. Typically, what we want to be looking at is 5% organic matter. At Profile, we use the expression strive for 5. And that's because we want to see around about 5% organic matter in that topsoil. The rest of it is going to be made up of air, water, balance with minerals. And minerals, we're just talking about what is the composition of the soil. Is it sandy? Is it rocky? Is it silt? Is it loam? Is it clay? So we're looking at all those various other factors blended in there. But organic matter is very important because that's where all the bioactivity goes on for that nitrogen cycling. So typical construction site, this is what we see as our horizon. That top 12 inches is gone. One of the first things they do is a residential development or even highway construction is they often will pull that topsoil off. Typically in construction, we don't want to have that topsoil in place because it's compactable. It doesn't hold up very well. If we've got heavy buildings or roads or whatever going on top of it, we typically want to get back to that subsoil. We've got good, hard, compacted soil that we can put whatever structure on top. So topsoil gets pulled off, and in the past, there used to be they would just sell it off as part of the development. And then later on, they would bring back in the minimum they needed to cover up and plant some seeds or just put sod straight on top of that subsoil. If we want to be successful, we need to make sure that we're looking at testing this area of the soil. So we want to be testing subsoil if that's what we're dealing with in our plan to revegetate. And there's various solutions that we can do to kind of get around the fact that this is basically sterile soil that has been denuded and is devoid of any organic matter or nutrition for plants. So key elements of healthy soil, minerals, obviously, we talked about NPK, biological activity. Now, in the organic matter layer, this is where all the biological activity is. So this is, all our protozoa, our worms, nematodes, basically anything that is going to break down the organic matter is living in that organic matter layer. The reason this is important is that plants don't have the ability to properly absorb nutrients without this biological activity breaking it down. It makes it more accessible in a form where the plants can take it up. So if you've got sterile soil and you just put NPK down there in the right quantities, you adjust for pH, and you have no biological activity, you'll be successful for a short period of time. But once those plants have got past the point of absorbing all the nutrient from the seed and the germination process, they'll start to struggle because they'll have trouble accessing, basically any of the nutrients in a usable form. The biological activity breaks that stuff down, the NPK, and makes it available to the plants in a form that they can consume. So additionally, we have to have water in there, and that water in combination with the organic matter gives us a living surface layer that's going to regenerate our topsoil layer. And as plants grow and decay, we'll start to regenerate and regrow that natural topsoil area through bioorganic activity. Air is also important. This comes into the factor of if we have soil that's completely waterlogged, too much water is not a good thing. If there's no air access to the plant roots, they can't grow. And it's the same thing with compaction. If the plants can't get into an area where they've got access to some air and some water, then they're not going to be successful either. So agronomic amendments, fertilizers, soil neutralizers, we kind of focus on this a little bit. We can also increase our organic matter. If we've got these denuded construction soils, we can add organic matter back in there. There's various methods we can do that. We can also add growth stimulators and enhancers. So that's, again, increasing that bioactivity and giving, long-term plant vitality. So strive for 5, as I mentioned, we're looking at 5%. Typically, when we look at construction type soils and we do soil testing, we're typically looking at 1% or less in terms of organic matter. The reason, again, this is important is organic matter not only holds the bacteria at that surface level where the roots are and the plants are trying to grow, but it also is responsible for maintaining a large amount of the moisture in the soil. Organic matter will increase moisture levels in surface soil significantly and also helps to reduce the transpiration of moisture from the soil. So for every 1% increase in organic matter, basically you get somewhere between 16.5 to 27,000 gallons per acre of water holding capacity. This is studies that were done on farming properties where they incorporated things like organic matter compost, rice hulls, straw, etc., into the soil, and then looked at what the water holding capacity was. This is a study done back in 2013. So organic matter is critical to establishing that correct balance in that soil after construction. So we can add topsoil. I would give a caveat with bringing topsoil in. The term topsoil is really quite a confusing term because it means lots of things to lots of different people. The thing that I'd be most concerned about is, again, if you are bringing topsoil in a project, have it tested, just like you would test the soil that's there. So if you're going to put a 6-inch cap of topsoil, test that soil. Don't assume that it's amended and assume that it's in good condition for growing. Make sure you test it. Compost is another one. We can bring compost in. We see in a lot of states compost being brought in and being incorporated. Compost is a great product for increasing organic matter in soil. Again, you've got to be a little bit careful with compost because if it is compost from curbside haul, it can contain pesticides and other deleterious. It can have plastics and metals and other things that you don't want to have in your soil. Peat is a good product to bring in. It's fantastic organic matter. The peat is the fact that, it is a limited resource and fairly costly to transport, since most of what we see in the way of peat comes from up in Saskatchewan area up in Canada. Manure and biosolids is a great product. You have to be a little bit careful with neighbors. They don't get very happy when you bring a manure spreader out and all of a sudden their neighborhood doesn't smell so great. So just a consideration. Wood chips, sawdust, great products. Typically, I would prefer to see compost versus wood chips and sawdust, simply because as wood chips and sawdust start to degrade, that carbon nitrogen exchange can be a little bit detrimental, and we can also see some decreases in pH as a result of the breakdown. And then there's biotic soil media, which is basically, here in the state of California, is known as HBGM, or hydraulic biotic growth medium. So all of these things can be added to increase our horizon when we've got that top layer stripped off. And we focus a little bit on HBGM. This is a product that we manufacture. The advantage of this is that we don't need to incorporate it. We can spray it over the surface of the area. This is going to reintroduce basically biotic media. It's going to increase plant nutrition. It's going to have over 200 types of biota in there. In addition to that, this is going to actually start that nitrogen cycle, and we're going to start seeing that regeneration of topsoil. Again, big plus is that this can be sprayed in. You can cover large areas of it. It reduces the amount of truckloads of topsoil or compost that need to be brought in. And again, I am aware in certain states that there are requirements to put compost in. Don't have an issue or problem with that. Obviously, you have to follow whatever the state guidelines are in the state that you're in. So part of the thing that one of the advantages, I guess, of the biotic soil media is what you're getting every single time. You don't have any concerns about introducing vectors in terms of plant diseases. You don't have any concerns about introducing potential pathogens, pesticides, etc., even residual pesticides. So you know what you're getting. It's the same every time. It has endomycorrhizae, humic acid, seaweed extract, so that you've got beneficial bacteria. So you're actually going to get into reestablish that cycle. So as mentioned, we're trying to get to 5% organic matter. Application rates on pounds per acre. If you're at 2 to 5%, typically about 3,500 pounds per acre of HPGM. If your organic matter is below 1, you're looking at about 5,000 pounds. Again, in this, we can add seed, we can add fertilizer, we can add amendments, we can add pH adjustments if we need to. All can be added in the same tank. This is an approved product. It is actually specified as a engineered soil. So there's ASTM testing on this. So if you need information and specifications on how to use this, we do have that information available. Again, what we're doing is we're looking to reestablish this top 12 inches. What's been removed. So we're going to take that B horizon and try and recreate that A and O horizon into the B horizon by adding organic matter and biotic soil. This is what the product looks like. On the left is how it arrives, 50-pound bales. This is what it looks like mixed in the tank in the center photo. And then that's it being sprayed out and applied. Typically, when we're applying this product, we are going to be requiring an erosion control product to be put over the top of it. So we would spray this out with any amendments and seed, and then put an erosion control product over the top of it, just to make sure that it stays in place. Nice thing about application on this is we get into all the little nooks and crannies and get good coverage with this. So in areas where compost gets incorporated, we see a lot of 2-to-1 slopes, and I would challenge anyone to incorporate compost or add topsoil to this slope. So just a good example is of certain areas where this is a highly applicable solution. So second fundamental is picking the right plant species. And talk a little bit about this. Questions you need to be asking yourself is, do you need to grow plants in the project? Where is the project? What's the aspect? What kind of soil do you have? You did soil testing, so you know exactly what you're dealing with. Is this permanent or temporary vegetation? And when are you going to be installing it? These are critical questions to know about the project. And for many of you, maybe this has already been done by somebody else. I have seen many projects. I was a hydro seeding contractor for 5 years, and I saw many projects that were designed to go in fall or winter, and they had a fall or winter seed mix, and the project got pushed to spring, and we put the seed mix down, and it wasn't particularly successful because it was the wrong seed for that time of year. Just make sure that if projects do get bumped, that you're paying some attention. Talk to the seed expert on that and say, is this still applicable? So again, intended application. What are you doing? What are you trying to achieve? With seed, I always say consult the seed expert. The reason I always push this off to a seed expert is because they know what's going to grow in the area of country that you're in. They also have had plenty of experience with projects that have not worked with seed. So they're the best people to go to. It's really hard to kind of encapsulate and say, use this or do that with regards to seed. It really is very regional. In some areas, it's hyper regional, especially if you're dealing with state projects that want to have specific seeds grown in certain areas that are biotope for the area where the project's being done. So again, always consult with the seed expert. Make sure that you're getting the right product being applied for the time of year and for the end goal. So number 3 is selecting the right erosion control material. This slide here, because back in the 60s, this is what slope stabilization looked like. People have often asked me where these photos were taken because they want to go and find those cars and do some kind of reclamation project on the cars. I don't know where these are from, somewhere in California. That's all I can tell you. But yeah, this is what used to qualify for, slope protection and erosion control. Nowadays, erosion control, you have plastic, visqueen, good solution if you're looking at carrying through one storm. You just got to get it covered. It's a small amount of area. You can roll the stuff up and reuse it on a future area. If it's long term, you don't want to use visqueen. It's going to blow around. It's going to break down. It's just a mess. You can use rolled erosion control products, blankets, coir netting. You can drill seed. That's often used for a lot of solar projects we see these days, where it's fairly flat, easy access, and not too rocky. Straw and tack is a little bit more old school. That's in that top left picture. Still gets used a lot in the West, mainly due to the fact that straw is widely available, although we have seen seasons where it is not widely available and the price goes up. So, and then there's hydraulically applied. That's the bottom right, which you can see being spread out there. And then there's soil binders and dust control if you're just looking at temporary stabilization for wind erosion. Hydraulically applied, the big advantage is that you can apply it to large areas very quickly. You can customize it to your site-specific conditions, and it is environmentally safe. It's basically pure organic matter and fully biodegradable. It does cut down on labor and cuts down on costs, and we get that nice intimate soil contact when it's sprayed down. So talking a little bit about the slope versus product. In the bottom of the market, we're looking at straw, that's in blown in straw, some basic hydro seeding or hydro mulching. As we go up the slope a little bit, we get into things like bonded fiber matrix. We get into rolled erosion control products with nettings A, B, and C, and you got hydro seed in that arena too. And then as you get a little steeper still, you're now talking about ABC RECP blankets and fiber reinforced matrix. So you're now talking about a flexible growth medium, a much more strongly bonded wood fiber product that can be hydraulically applied. And then when you get above the level of stabilization with vegetation, you start getting into adding turf reinforcement mats. And then if it's extreme, you're talking about hard armor where you're at to be your riprap and concrete channels that we see around. So a little bit of information about what goes into a hydraulic product. You've got fibers. They can be wood, cellulose. They can be recycled paper. You've usually got a tackifying agent either already in the product or added to it. So this can be guar, plantago are typically the two most common binders that we see. And then we do have things like polyacrylamide, and again, that we'll go down a rabbit hole if we get into that. There's lots of different options available in there, and typically I recommend discussing it with your manufacturer. So thermally refined wood uses heat to break down it. So we take a wood chip, as you can see in that top picture. When we process it, it's coming from chips from the furniture industry. It's usually a blend of hard and softwood. We put it through a big steamer, pressurize it, and then it goes through a couple of mills that will grind the fibers out. And we end up with a fiber like you see in the middle and end pictures. And what this does is it gives that, you've got those nice little tendrils on it. It keeps the moisture at the soil level and creates the perfect environment for seed germination and growth. In tackifiers, again, we're looking at natural organic polysaccharides, so psyllium or plantago. That's the same stuff that's in Metamucil. Guar gum, which is basically the same stuff you see in ice cream and salad dressings. So various food products. And starch, you've got potato starch and other starches, cornstarch that get used. These all get used on large scales, completely organic, biodegradable. They'll break down with no complications, no contamination issues for fish or other creatures. When we start getting into polymers, we're talking about the polysaccharides and chitosan. Check with your local authorities whether you're permitted to use them, especially if you're near bodies of water. I'm not going to go into too much detail on these, except for sometimes you'll see the term cross-linked polymer. So what this refers to is this will be something like, for example, a guar gum that's been exposed to heat, pressure, and pH. And what it does is it creates a non-reversing bond. So when you mix a cross-linking polymer with water, it basically is non-reversing. So it stays and keeps its tensile strength when it gets re-wetted by rain events. So in terms of the market for applying hydraulically applied, you've got paper, then you've got wood, and then BFM or stabilized mulch in the middle, and then the bonded fiber matrix or flexible growth medium fiber reinforced matrix at the top. So this is actually a product called FlexTerra. This is actually a flexible growth medium. And you can see one of the big advantages of this is when you spray it down, it gets that intimate ground contact. And this has been picked up after about a day of application, and it's firmly bonded onto that soil and gonna give a nice connection. You can see this is applied on a project down here in San Diego. They sprayed hydraulic biotic growth medium down, and then they sprayed a bonded fiber matrix over the top of it to make sure it didn't erode. You can also incorporate this with core netting, wattles, etc. So integration of various BMPs. Why do we do this? We're doing this to prevent erosion. And basically, I don't know how familiar you are all with the revised universal soil loss equation, but when we look at this equation, you'll see in here we've got RK, LS, CMP. The reason that we like to talk about this is that the only ones we can really affect significantly are C and P. We can design to reduce slope length or steepness, but in terms of vegetation and cover factor, that is the product we select is very important for that. And on the erosion factor, that's the ground preparation. Is it track walk or is it just smooth slope? So those are factors that we need to take into consideration. And of these, probably the most important is the vegetation or the cover factor. So this is the R, which is the rainfall. This is K, which is the erodibility of soil. You can't affect this. What you've got is what you've got, depending on what your construction site is. The only caveat to that is you can bring different materials in and incorporate it, but it's very expensive. L and S, again, design. You can make the slopes longer or flatter, or you can put terraces into, kind of slow flow. But on C factor, this is where it becomes important. With C factor, it's very important to understand, if it's vegetation, at what point do we have fully established vegetation? Is it going to provide, the C factor that we need to see to reduce erosion? We do test for this on products. Large scale lab testing is done for C factor. This is product that's applied and then gone through rain events, simulated rain events, and then we gather the soil at the bottom to see, how much soil has come off that slope area. We do this in Texas, and we also do this in a lab in Utah. With C factor, something that's important to understand is that the soil stabilization C factor, the smaller number is better. You want to have a smaller number, not a bigger number on C factor. And again, the P factor is about how do we prepare that soil? Is it disked? Is it track walked? Is it smooth? Those are all factors that come into it. So when we're looking at a slope stabilizing, this is one that was sprayed with a hydraulic product and had some growth coming into it. We want to look at that comparatively to mats and blankets. On this slope, you can see soil preparation. There's a lot of rockiness and undulation in this. If you would put blankets or mats on this, you would have difficulty getting, all those voids out. You'd have plants emerging and then pushing out the blanket underneath. Functional longevity is something that gets asked, and basically this is dependent on the amount of moisture and the microbial activity you have. Typically, products will have a standard amount of time that they've got on in terms of the functional longevity. Typically on a base multi-material, it's 3 months functional longevity, and we're looking to get vegetation established. So when we're looking at vegetative establishment, there's a 21-day test, looks at how much vegetation comes up with an untreated area. And then we start looking at different materials with regards to if we got blanket on there or we got mulch on there, how much more vegetation do we get during that same time period in terms of germination and establishment. Ensuring proper installation. Might seem like a no-brainer, but this gets missed an awful lot. We have a situation where people don't pay attention to getting correct installation. There's always a set of plans, guidelines with regards to specifications. Make sure the specifications are followed. Doing things like bags and tags. So you're actually, looking at how many tons of material do I have to have applied? If I got 2,000 pounds per acre of material going down, do I have 2,000 pounds of material delivered to the site to make sure it gets installed properly? Follow the specifications. We do provide, for all our products, we provide application mixing guidelines. So those can always be, provided to help follow along. And then again, this gets back to if you've got a tank size of 3,000 gallons on a hydroseeder, 24 bales goes in there at 3,500 pounds per acre, you'd expect to see 15,000 pounds. This is really important if you're inspecting sites to make sure you're getting what you're paying for. Always have a look at it. Again, if it's 5 acres of area at 2,000 pounds, there should typically be 5 pallets of material there. If there aren't, you probably want to ask the contractor where the missing pallets are. Application rates are important too. This is a good example of 2,000 pounds versus 3 versus 3,500 versus 4,000. And you can see once you get to about 3,000 pounds, you're more or less getting complete coverage. And at 4,000, you have 100% coverage. So proper application and good coverage is important. When hydroseeding, especially anything over 2,500 pounds, you want to make sure that the product is sprayed from at least 2 directions. You can see on the right there, this product was sprayed from the left to the right. So if you're standing at the top of the slope looking down, it looks great. But if you stand at the bottom of the slope and look up, you can see what's called shadowing. And shadowing will lead to, opened up areas and exposure. If you can't get to 2 sides of the project, we recommend lobbing product in and having it land just like the rain so it fills in and covers the pockets. Mulch rates do make a big difference. Here's an example. This is a test plot that was done. This is 18 days after seed was installed with 1,500 pounds per acre of mulch. This is exactly the same area right beside it with the same seeds, same fertilizer. The only difference here is the mulch was increased by 1,000 pounds per acre. You can see quite a bit more vegetation. And then this is right beside it with 3,500 pounds of mulch. You've got, a much, better establishment of vegetation. So people say, well, what difference does the mulch make? The difference it makes is the amount of moisture it retains in the soil and keeping that moisture at that seed level and providing a better environment for germination and establishment of the plants. One of the things to consider is that when you're looking at a construction project or a revegetation project, this is obviously an insignificant value in terms of the overall project cost. So if you have an opportunity to increase, mulch by 500 pounds per acre, we certainly recommend doing it. There's your comparison between the three of them. It is a very small percentage of the overall project cost. Basically, again, the only difference between these three is the amount of mulch applied. So fundamental number 5, inspection and maintenance. Never ceases to amaze me how often people get projects finished and they don't go by and take a look at it when it's done. I seriously suggest that inspecting upon completion. The other thing to also do is inspect out. If you've got blankets on your slope and you've got some seed coming through it, go and have a look for flumes of sediment. If you've got flumes of sediment appearing at the toe of the slope, you've got erosion going on underneath that blanket. If you've got a situation where it was sprayed with hydroseed and you start to see a rill open on that slope, make sure it gets fixed before the next rain event. So go check it after the first major rain event and look for the weaknesses and the failures on the site, because it's a little bit like, pulling a string on a sweater. It's very easy for the whole thing to unravel, but if you can take care of just stitching that string in place, then you don't have so many problems. So inspection and maintenance is very, very important. Suggest having somebody who knows what they're looking at go look at it rather than just dispatching anybody. Might seem like a no-brainer, but I have seen many times where they send somebody who's brand new to go look at inspect the sites. They don't know what they're looking at, and they may miss problems or potential problems. Make sure that it matches what the plans say. You should have had a sign off on the project when the project was completed and inspected that it met all the requirements of the plans. Again, go after the first storm event too and just check and make sure everything's holding in place. It's far cheaper to get somebody in to fix the problem at that point in time. And then subsequent inspections typically is, go for the second rain event or do a predetermined space. So a week in, 2 weeks in, a month in, and just look at what's growing in. So here's the site. This is the day that it was sprayed. This is actually in the East Coast. So vegetation does tend to grow a little faster in the East Coast. They have a little more rainfall and temperature faster growth than perhaps in the West or the Midwest. This is a week later, and you can see in this particular case that a lot of the material was sprayed from the road, and so you've got a lot of seed gathering up in those in the bottom of those track walk rills. This is 2 weeks later and a month later. Now, when you look at this site, you'll see that there's little pockets here and there where there's not a lot of vegetation. There's one on the left-hand side of the picture and a little bit on the right-hand side. When you look at this from the roadside, you actually see pretty much 100% coverage. So in those areas, perhaps there's an issue where there's some kind of contamination in the soil. We've seen areas where a slope doesn't have any vegetation growing on it, and it turned out that that was the area right beside where the concrete washout was, and perhaps the pH of the slope in that area is contaminated. So again, things can be done to fix that and correct that, before you get into major storm events. Could possibly go wrong? Well, here's a site where the contractor followed exactly what was in the plan for the design for this particular slope. They sprayed a bonded fiber matrix on this slope. There's a fairly concentrated flow area down the middle there. The soil was compacted correctly. There's no track walking evident here, so it's a fairly smooth slope. And there's also no slope interruption. So no straw wattles to break down that flow coming down the hill. 50-year storm was the first storm event that came through, and it was an hour after it was applied. Given that it was a bonded fiber matrix, it didn't have enough time to set up properly, and that storm event just basically came in and just washed it out and then continued to erode the slope. That one tree is the only piece of vegetation, and it's not enough to stabilize this slope. So end result was fiber rolls and silt fence were installed, silt fence to capture anything that may potentially come off in future. The GC had to go back and refill all the rills and recompact the slope. And then in their design, they put some slope interruption in, added some straw wattles, and then they went back through and sprayed it again to reseed it and give it a chance to, kind of get in and establish, the vegetation. Question I would be asking at this point in time is, would it have been better just to have put all those measures in the first place? Or is it better to come back and fix it? I think it's far more expensive to come back and fix it. But we do see plans on a regular basis where, this is what is done. They, try to cut costs, don't put in slope interruption. That being said, if this were a situation where you were spraying something like a flexible growth medium on here, or you had enough time to establish vegetation before the storm events were coming in and you're irrigating, then it'd be a totally different story. So again, it comes down to that. What is your goal? What have you designed this for? What time of year is it? And what are your chances of getting your vegetation established before the rain comes? Reapplication is always far more expensive than having, spending a little bit extra money and doing it right in the first place. This was the end result after the reapplication. And it was a fairly successful reinstallation. Interesting thing on this one was soil testing was done on this before the initial, and amendments were put in. But the unfortunate thing was that the design of lack of slope interruption was where the major problem was lying. So again, we covered, creating optimal soil conditions, picking the right plant species, selecting the correct erosion control material, ensuring proper installation, follow-up inspection, and maintenance. These are all equally important. It's important to balance these through your project. Some may be more important than others, depending on what your project requirements are. If you follow these guidelines, you will successfully establish vegetation on your projects, and get to a position where you can get an NOT and get onto the next project and get paid. So a couple of case studies. This is a fire that burned through 20 acres down in Rancho Cucamonga in December of 2017. This is what it looked like after they started doing some reclamation. They got in, took out large debris, put in some straw wattles, and they took some soil samples. We found that organic matter was 1.5 and 2.2. We took it from a couple of different areas on the site, and then had a recommended prescriptive solution for application. We added some biostimulants, put bonded fiber matrix in at 3,000 pounds, and then this was the seed mix that was selected. This is the application process, and here they're applying a hydraulic biotic growth medium and then putting a bonded fiber matrix over the top of it. In this particular contractor's got two trucks going, so one is spraying the HPGM and the other one's following behind and capping it with the erosion control with the BFM. This was February of 2018. This is right after the application process. And then this is April, 55 days later, where we're starting to see seed germination. I would venture that if soil testing were not done on this, you wouldn't see the success rate that you have. Caltrans Highway 154. This is after stabilization. Again, important that we've got all those straw wattles going down the slope. Even with vegetative establishment, that's going to exceed our capacity to stabilize if we don't have the slope interruption in there. And that's after it's grown in 6 months. Something that's really important to understand with native erosion seed mixes and wildflowers, is that you don't always get these beautiful fields of flowers quickly. A lot of the native species can require between 3 and 5 years to grow in and establish themselves. So just be aware of that. It sometimes takes 2 or 3 growing seasons before you start seeing some of especially the wildflowers coming up. So we do have for soil testing, we do have a free program called PS3. The address for it is profileps3.com. You can sign up. It's free registration, and you can go and take soil tests. You can send them in to our lab in Ohio. All you do is cover the cost of the soil sample being sent in. We can walk you through the process and give you any help that you need in the process. But we really do this to try and make sure that more soil testing is done than we're currently seeing. If you enjoyed today's presentation, please feel free to shoot the QR code and give feedback. If you didn't enjoy it, please feel free to shoot the QR code and give feedback. We only get better if you give us feedback. So, please feel free to participate in that. Just scan that QR code, and I think it's about 6 questions. If you do it, you'll also go in a drawing for a $50 American Express gift card. With that, I'm going to ask if we have any questions.
Awesome. Thank you, Colin. We do have a few questions here. Let me find them really quick. Mel asked, I always forget organic matter is different from organic material and what the difference is between them.
So the terms are fairly interchangeable. So, but typically organic matter is the material that we're incorporating into the soil to provide structure. So we're looking to, if we've got, for example, 80% sandy soil, and we can incorporate 5% organic, we exponentially increase the amount of moisture retention, and we also give an area where we can get that biota established, and all that bacteria and enzymes, et cetera, that can be in that soil. So the terms are not too different. The organic material is basically organic matter when it's incorporated in the soil.
Awesome, thank you.
Did that answer the question?
I believe so. Mel, if you want to let us know if that did. Here's another question for Mel. The Flexterra from Profiles worked very well for us. Oh no, I lost it. Sorry, let me start that over. The Flexterra from Profiles worked very well for us. Are there any comparable products that you are aware of?
That's a tough question. The answer, honestly, is not really. It does stand out. If you're talking about bonded fiber matrix, which is kind of next level down, yes, there's multiple options in the market. But on the Flexterra level, there really isn't anything in that same category. There are equivalents that can be specified. You can certainly look on like QPLs or APLs in your state to see, what's on the approved list, and you will find in that category you may find others. But in terms of performance, I think that Flexterra is pretty much a standout. And the reason for that is you get about 18 months of stabilization and erosion control. It does increase the amount of moisture retention at the seed level. And you do have, almost 2 years for that seed to get in and establish itself before you start seeing degeneration and degradation of the erosion control material.
Awesome.
I'm glad to hear it works for you.
I have another one here. To ensure the final sprayed slope is protected from excessive run-on, Do you have any recommendations to encourage sheet flow?
Yes. That's an interesting one. When I was a contractor, I worked on a project in Napa, and we had beautiful clean water running through the property, and there was a vineyard basically uphill from this project, and we found water running on initially, and so we actually blocked it, and we sandbagged it and diverted the water so it stayed on their property and didn't come onto ours. And the following day we came out after a rain event and there was dirty water, and basically the workers in the vineyard had removed our blockade to allow the water to run back on. I would say that there's a couple of things to do. Either convey the water through the property, so either through piping or ditching or some other conveyance. You can even create a ditch with visqueen. Otherwise, you're looking at probably your best option is going to be something like straw wattle or compost sock, just to put laterals in to slow that flow down and spread it out in sheet flow. It probably is the best solution for that spreading out for sheet flow.
Great, thank
I
you.
do prefer compost sock to straw wattle, simply because compost sock has a tendency to flow through and pick up sedimentary material on the way through. That being said, it's not always practical to drag a compost sock on a 200-foot long slope. It can be, very heavy and difficult to install. So
Awesome. I have another question here from Alexandra. For industrial sites that are required to monitor stormwater for nitrogen, are there ways to reduce the potential for nitrogen and stormwater runoff from areas where compost or amendments have been applied?
There are typically on those post-construction sites or industrial sites, you can actually put products into catch basins that are designed to pull nitrogen and nitrate products out of that stormwater. It's not an area that I'm particularly well versed in, but I did work at Filtrex for a period of time, and we actually use compost for removing nitrogen. The big problem with the term compost again is that sometimes it's well aged, sometimes it's not. So it means different things to different people. Typically, compost should not be releasing any nitrogen into your stormwater. Again, a lot of it depends on what it's composed of. I would recommend looking at a catch basin type product and putting a nitrogen removal filter in there. If you need more specifics, you can reach out to me. My contact details are on this slide, so if anyone needs to, go into something in the nitty-gritty or details, or get references to someone else who may be able to help, feel free to give me a call or send me an email.
Great, thank you. I'm not seeing any other questions at the moment. Oh, here's another one. From Mel again. Would we expect HBGM to have a nitrogen runoff?
No.
All right.
That's a nice quick answer. No, no, it is stable. Typically, if you're going to see nitrogen runoff, it's going to be as a result of fertilizer that's being put in as an amendment. Because even though we are using HPGM, we're actually adjusting that nitrogen cycling process in that topsoil horizon and introducing organic matter. So you can be adding an inorganic fertilizer to that. You could be adding a 777 or whatever it happens to be to that mix. That's where I'd have the caveat. So if you're concerned about that, make sure any fertilizer that's being added is a slow release fertilizer.
Great, thank you. And then I have another one here from Amelia. Any recommendations for getting seed to set on partially shaded sites?
So seed establishing on shaded sites, that honestly is a seed expert question. Pacific Coast seed or if you're in California, or SNS if you're in Southern California, would probably be a better source to speak to on that. They will usually have a very good idea, or any of the seed suppliers will usually have a very good idea of what will and will not work in shady areas and what's going to be successful. And they can usually base it on, the biotope for the area you're looking to establish that vegetation. There isn't really a solution from a fertilizer or a hydraulic application. You can obviously add things like biostimulants and bioenhancers to help get that growth to be optimal, but it's not necessarily going to be any more successful because it's a shady area.
Awesome. Thank you so much. I'm not seeing any questions at the moment. If anybody has any other questions, then go ahead and put them in the chat, or if you'd like to unmute, you can absolutely do so. I would like to thank you, Colin, for coming out and presenting for us today. It was a really great presentation. I know I certainly learned a lot. Thank you, everybody else, for joining us for Stormwater Awareness Week this week. It's been a really great week full of lots of education, and it's just been really fun for sure. If anybody has missed any part of this workshop or would like to view it later, a recorded version will be available in the next 24 to 48 hours on stormwaterawareness.org. We have one more presentation workshop coming up at 3 o'clock. It is the National Nightmares Eerie Episodes from the Water Quality Calamity Crypt. That was a mouthful, but that'll be brought to you by David Franklin. So if you have any more room on your calendar for some more workshops, go and check that one out real quick here. So thank you again, Colin. I'm not seeing any more questions. We'd love to have you out here again next year.
Thank you all for getting on. And again, please feel free to take my details down. If you've got questions ongoing, if you've got a project you need some assistance with, feel free to reach out. If you're not in California, I can certainly get you in touch with one of my colleagues in other parts of the country that can provide some boots on the ground support for you. So appreciate you getting on, and you guys have a great day.
Great, thank you.
Thank you.